Hey everybody, so today I'm going to be showing you how to use our reflection rules, our rotation rules, and how to carry out a translation given a pre-image or image on a coordinate plane. So last class we kind of went over the properties of each of these isometric transformations, also known as rigid motions. And here in this diagram you can see this is a reflection being carried out. Remember, one of the biggest things is knowing what the line of reflection is. So in this case, it's M. And also remembering that these distances here between the pre-image and the image, the line of reflection is a perpendicular bisector to those. Okay, so we've got our pre-image, our original image, and then our image, the one that has undergone the transformation. Okay, so remember these reflection, rotation, translation, they're all isometric. They preserve shape and size. So these are the new rules here that we haven't quite looked at yet. These are the coordinate rules that help us understand what is happening to each coordinate of our pre-image as it undergoes a reflection. And so it matters, remember, what the line of reflection is. That's going to determine exactly where a figure is going to go. So in this first one, our line of reflection is the x-axis. So when we reflect over the x-axis, any point, any xy, is now going to change into x comma negative y. So the sign of y changes. I'm going to write that down. The sign of y changes. Okay, so if it was a positive number, it's going to be negative, and if it's a negative number, it's going to be positive. So let's go down to this example here. So I know the writing's small, but it says, you know, our point A is -1, 4. So I want to reflect this over the x-axis. So I'm going to keep the same exact x value. So -1 will be the same x value on my pre-image and my image. And then now I'm going to take my y value and I'm going to change the sign of it. So this is going to become -4. Okay, and if you think about that, let me just draw a little coordinate plane here. When we're reflecting a point, so -1, 4, somewhere around here is A. When we're reflecting a point over the x-axis, what am I changing about that? I'm changing just the y coordinate to be negative now, right? We went from 4 to -4. And the fact that this was at -1 stays the same on the x-axis. So I could carry that out again right here in this example. So reflecting over the x-axis, the point 3,3, x stays the same, y changes sign. All right, so that's a reflection over the x-axis. What about a reflection over the y-axis? So a reflection over the y-axis acts similarly, except this time x is going to change sign and y will stay the same. Let's look at y. So in this example, I have the point 0, 2. B is right here. So if I'm reflecting over the, you know what, that's a bad point. Let's do 2, 2 instead. This is B. We're going to change that. We'll go back and talk about why I changed that. So if I reflect B over the y-axis now, I am moving over here, and that's going to be B prime there. So I am changing now, you know, my y value stays the same, but my x value is changing from 2 to -2. Okay, I'll write this a little bit here, B prime there. So my x value changes sign, and my y value stays the same. So the reason why I changed that is because this was originally a point that was on the x or on the y-axis. So I'm going to come down here to show you this. So say I have a point that's on, in this case, my line of reflection. We'll call it B again. So if this is on the line of reflection, where is it going to go when I reflect it? Nowhere. So points on the line of reflection stay on the line of reflection. Stay there. Okay, something to keep in mind. So then up here we said, we go back to our original idea, the sign of x changes. So then we have one more example here. I've got c is -7, comma -2. So we're reflecting over the y-axis. So I'm going to change the sign of x. So -7 is now going to become +7, and I'm going to keep y the same, comma -2. All right, and then this last rule is, what if we are reflecting over the line y equals x? Well, what line is the line y equals x? That's just this horizontal line that runs right through the origin. So if I'm reflecting over that line, say we have some point 5, 0. When I reflect over that line, I'm going to end up at 0, 5. So the rule for this reflection is we just switch x and y. So if I had a problem down here and I said now point E is 2, 3, and we reflect over the line y equals x, then E prime is going to be just the flip-flop of that, 3, 2. All right, so use these reflection rules to help you carry out reflections on coordinate points. It's really quite simple. If you have these rules, you can then tell me where a figure is going to end up if you know its coordinate points. So if I had a triangle on a coordinate plane, I could, here's my triangle, right? If I have all 3 vertices, I can then use those coordinates, apply these rules, and say exactly where that image is going to be after it's reflected over whichever one of these it may be. All right, so this is supposed to say rotation rules. So next up, we have our rotation rules. So when we used our reflection rules, these are going to look exactly the same as those. Probably why that said reflection rules. So in a rotation, remember again, we have the center of rotation. Right here, in this case, it's just the origin. And we have the angle of rotation. Okay, always going to be notated right here. And when we're carrying out our rotation, if you remember last time, we talked about how points closer to the origin or to the center of rotation are going to move less than those further away. And the other thing is that if we had, say, a point on that center of rotation, that point's going to stay on the center of rotation after that rotation is carried out, just like points on the line of reflection that we last saw. So here are our coordinate rules. Let's look at a rotation of 90 degrees first. When we rotate 90 degrees, we flip x and y, and we change the sign of y. So let's try it right here. So I have point A is 2, 6. So I am going to switch them. So 6 goes here, 2 goes here. And I need to change the sign of y. That becomes a -6. Okay, let's try with the next one. 5, 6. Switch them and change the sign of the first one. All right, 1, 1. Not much switching to do there. Change the sign of the first one. And so when I go and I plot these, so -6, 2, -6, 5, and -1, 1. So that was A prime, B prime, C prime. Here is my rotation of 90 degrees. It should look like a rotation of 90 degrees. Right there. So this pre-image went to that image. Color that in so you can see it a little bit better. So then the next rotation rule we have is for rotating 180 degrees. Okay, the rule is we change the sign of both x and y. So keep the coordinate exactly the same, change the sign of x and y. So in this first example here, D is -7, -2. So a rotation of 180 degrees, the image is going to be 7, 2. -2, 3, -2, -3 is going to be +2, +3. And -2, -7 is going to turn to +2, +7. Why is that? Well, because we are taking that pre-image and we're moving it to the opposite quadrant, right? So if I'm in the third quadrant here, I have all negative coordinates, I'm going to move to the complete opposite quadrant, the first quadrant, which has all positive coordinates. So 7, 2 is A prime, or D prime, sorry, in this case. 2, 3 is E prime, and 2, 7 is F prime. So we're going to do a little overlap here. So you can see, let me get a different color highlighter. You can see that this figure, don't compare it to the ABC figure at all, is a complete 180-degree rotation from this guy. And so the last rule, I don't have an example for this one, is rotating 270 degrees. And that rule is you switch X and Y and you change the sign of X. What do you think a rotation of 360 degrees would be? What would that rule be? If I'm going 360 degrees, I actually just end up right back where I started. So we don't actually carry out anything on that. We don't change anything about that coordinate. You're going to end up right back at the original coordinate. All right, so these are your rotation rules. And the last thing we need to talk about are translations. So there's no general rule for translations. You just need to be able to interpret the translation rule for each problem. So remember, translations are slides. So on my coordinate plane, if I'm taking a triangle, ABC, and I'm sliding every single point the exact same distance in the exact same direction on the coordinate plane. That'd be, so all those lines are going to be the same. Like, so in this first part, I want to determine the translation rule. So I want to know what happened. So in my pre-image, A was 1, 1, and in my image, A prime was -2, 4. So what you want to ask yourself is, how did you get from 1 to -2? What did we do? Well, if you think about it, to get from 1 to -2, I subtracted 3, right? Because 1 minus 3 is -2. So the way I'm going to create this rule is I'm going to describe that as X minus 3. All right, and then the same thing, this one's going to be a little bit easier. How did I get from 1 to 4? So if my number, if I'm going from a larger to a smaller number, we know we're going to be subtracting. If I'm going from a small number to a big number, I'm going to be adding. I added 3 to get 4. So this coordinate is going to be Y plus 3. So the first space is always going to be X, something happening to X, and the second space will always be something happening to Y. So let's see this one. How did I get from 0 to 6? I added 6. And how did I get from 0 to -1? I subtracted 1. And you can check if this works or not by taking this point, 1, 1, and I'll put in here 1 minus 3 is -2. 1 plus 3 is 4. 0 plus 6 is 6. 0 minus 1 is -1. All right, so that is actually, I think, the trickier part to this, coming up with the rules. We started more difficult, we're going to get easier here. Now I'm just going to apply these rules. So if I'm given my translation rule right here, I want to now apply it to this pre-image and find my image. Where did this point go on the coordinate plane? So all I'm simply going to do is I'm going to take my -4 and I'm going to substitute it for X here. So -4 plus 3 is -1. And 7 will go in for Y. 7 minus 5 is 2. And another way you can see this, we're going to skip to the bottom one, is in this vector notation. It looks like this, -1, -2, with the little carrots. This is the same thing as this, x minus 1, comma, y minus 2. Okay, vector notation, this is just indicating how many we're moving in the x direction and how many we're moving in the y direction, and the sign tells you in what direction we're moving. So if I were to carry this out on here, I'm simply just taking 9 and I'm subtracting 1 from it to get 8. And I'm taking -5, I'm subtracting 2 from it to get -7. And the last type of problem you can see here is that we're given a rule, we're given an image now, and we need to find the pre-image. Where did we come from? And this is the case where we need to consider what +1 got me 4, or what +6 got me -1. Okay, you can think about it that way and probably answer that pretty simply. But mathematically, you can think of this as almost x + 1 = 4 and y + 6 = -1. If you'd like to write equations out for yourself, if it helps, just set each of these rules equal to their corresponding x and y coordinates. So then here we can tell 3 + 1 is 4, and -7 + 6 gets me -1. You can just subtract 6 from both sides. Y is -7. All right, so use these rules to help you practice problems with rotations, translations, and reflections.